Okay, so this is going to be a step-by-step guide on how to solve these problems that we've been using for uniform acceleration. So let me type very quickly the equations that we will be using this unit. These will be given to you on the exam, so no need to memorize any of these. So we have VF equals VI plus A times T. We have VF squared equals VI squared plus 2AX. Originally, we gave you delta X. X is just for distance, so it's simplifying the problem for you. And X equals VIT plus 1/2 AT squared. So these are the only equations that you're going to be choosing from. We are not asking you to go back to last unit. It isn't F net equals MA. It's not the friction ones. These are the equations we're going to be looking for. So when you start the problem, start reading it, and we're going to be looking for clues on what each variable is that we have, and you'll find them throughout the problem. So a car is traveling at 45 meters. That's the first number I come across. So I'm going to highlight that. And that is a given, but it's not considered a given until I decide what it is. So it is traveling at and slams on its brakes. So it was doing 45 and now it's not doing it anymore. So that has to be my VI. I know that it's a velocity because it's labeled meters per second, and meters per second belongs to velocity and speed. So that's my VI, 45 meters per second. The next thing I come across is it slams on its brakes to slow down to 15 meters per second. Please notice it has the exact same unit on it. It's a meters per second. And I know when I see a VI, looks like I put a 1 instead of an I. When I see a VI, I think I should probably be able to find my VF, and that's what came next. It told me it was doing 45, and now it's doing 15, so that's my VF. I keep reading, and it says in 3 seconds. Seconds is the unit we use for time. So the third given I found is time. Now, we've said this in class a few times, but it needs to be repeated. Every single equation we have has 4 variables in it. This one has VF, VI, A, and T. 4 variables. This one has VF, VI, A, and X. 4 variables. This one has X, VI, T, and A. The T shows up twice, but it's 4 variables. So if I have a 4 variable equation, I have to be able to find 3 of them. Otherwise, I cannot solve the equation. Now I'm asking you 2 separate questions here. What is the rate of acceleration? And how far did it travel during this time? So I have 2 unknowns here, and I'm going to solve them separately. The first unknown is the rate of acceleration. So I don't know that one. So that's my first unknown. But the second question I asked is how far. So I know I'm also going to be solving for the X. So now I can look for the equation. I should not look for an equation until I have my givens done and I have my unknown defined. So when I'm trying to decide what equation I'm going to use, I need to look at my givens and I need to look at my unknown. So I have a given of VI, a given of VF, a given of T, and an unknown of A. So I have to look at the equations that have VI, VF, T, and A in it. This first one has all of my givens, the VF, 15, the VI, 45, the A is my unknown, and the T is 3. So that's the one I should pick. But before we move on, let's go through the other two and figure out why they're not right. So on the second equation that I have highlighted, I have the VF, it's 15. I have the VI, it's 45. I don't have the A, but I want the A, but I don't have the X either. So there are two unknown variables in the second equation. Therefore, I cannot use it. The third equation, I don't have the X. I want it on my second problem. I do have the VI. It's 45. I do have the T. It's 3. I don't have the A. So I'm back to the same problem I had with the second equation. I have two unknown variables, so I cannot use it. Okay, so I know the equation I'm going to use. Now I'm going to substitute in the givens that I have defined and put in the A, which is my unknown. So again, my VF is 15. My VI is 45. My A, I don't know. And my T was 3. Now I can solve the problem. Algebraically, I'm going to want to subtract 45 from both sides by 15 meters per second minus, I'll change colors so you can see what I'm doing, 45 meters per second equals 45 meters per second minus 45 meters per second. If I do it on one side, I have to do it on the other side. That's rules for algebra. So I put in red what I'm doing on both sides. I'm subtracting the 45 from both sides because I'm trying to isolate that A. 15 minus 45 gives me negative 30 meters per second equals A times 3. Now I'll add in again in red what I'm doing, negative 30 meters per second. I'm going to divide both sides by 3 because I want that A all by itself. So that'll get the A by itself, negative 30 divided by 3. My A is negative 10 meters per second. I forgot to throw in the seconds here. So it's negative 10 meters per second, which is negative 10 meters per second squared. So I have my A. The next question is, what's the displacement? So I'm actually going to take this A that I just solved and I bring it up as one of my givens. I'm going to make it the red color again. I didn't have this originally, but now I do. And because I have it, I can use it for the second half of my problem. So now I go through them again. I know I'm not going to use the first equation. I already used it. The second equation, I have my VF, it's 15. I have my VI, it's 45. I have my A, it's negative 10. I don't have my X. So because I do have all the information I need for this one, I can use this equation. Let's look at the third equation. I don't have my X, but that is what I want. I have my VI, that's 45. I have my T, that's 3. I have my A, that's negative 10. And I have my T, that's 3. I'm going to bring this down and I want you to see that I could use either one of these equations. I'm going to color code them. We'll make the second one, let's go with blue on that. So I'm going to start with the one that I left in black, and I'm going to solve using the VF squared equation. So I'm going to substitute in. My VF was 15. Sorry, I was in the wrong spot. My VF was 15. The only reason I'm going to do it twice is because I want you guys to see I'm going to get the same answer both ways. My VI was 45. Plus 2 times -10. Okay, continuing with the black. 15 squared is 225. -45 squared is 2025. Plus 2 times -10 is -20. Just like last time, I want to isolate my x. So the next thing I'm going to do is I'm going to subtract negative. Let's change back to red like I did on the last problem. I'm going to subtract 2025 from both sides. And when I do that, my left-hand side is -1800 meters squared per second squared. And that equals -20 meters per second squared x. Now the next thing I want to do is divide. I'm going to divide both sides by the -20. And that'll get my x by itself. So I have -1800 divided by 20. That gives me I'm divided by -20. So that gives me 90 meters equals x. So just to prove that both equations would work just as well, now I'm going to bring this equation down. We'll do everything in blue this time. I'm shooting for an answer of 90 meters, so let's see how we do. So x is what I'm solving for. My V initial, we said, was 45. My time is 3 seconds plus 1/2. My A was -10. And my time again is 3 seconds. This one might be easier mathematically because I'm not having from both sides and I don't have to divide on both sides. I'm just doing straight math here. So x equals 45 times 3 is 135 meters, plus 1/2 times -10 is -5. -5 times 3 is, or sorry, times 9 is -45. But let's show those steps. I did the half first. 3 squared is 9. So I'm going to do 2 algebra steps in one. So now I have x equals 135 meters plus -5 times 9 is -45 meters. 135 plus -45, I got the same answer as I did before. So I got a displacement of 90. Both ways I did it. And an acceleration of -10. I hope this helped.